Today I'm going to teach exercise number 2.5, differentiation. Question number 2 is differentiate the following with respect to variable involved. First question x gets secant 4x. Now we can see that in this question trigonometric function is involved. So first of all we have to know about the derivative of trigonometric function. And what the trigonometric function? Sine, cos, tan, cosecant, secant, these are called the trigonometric function. And we have to know about the derivative of these functions. So derivative of these functions, these trigonometric functions are, first of all, derivative of sine x. Derivative of sine x is equal to cos x. Derivative of cos x is equal to minus sin x. Derivative of tan x is equal to secant square x. Derivative of cosecant x is equal to minus cosecant x cot x. Derivative of secant x is equal to secant x tan x. And derivative of cot x is equal to minus cosecant square x. These are the derivative of trigonometric function. Now if we have given derivative of simple sin x, it means derivative of sin x is equal to cos x. Now derivative of sin 3x. Derivative of sin, we consider this term as x. Derivative of sin x is cos x. Cos, this is 3x, so we write 3x. And again we will, this is x, so we'll write x. This is not simple x, so again we will take derivative of this function. This is our angle. This angle should be simple, x, theta, y, whatever there is any variable or function. This is simple. If this is not simple, so we'll again take the derivative of this theta, and theta is here is not a simple 1x. This is 1x means 1. Now this is 3x, so again we will differentiate this angle. Now cos 3x and derivative of 3 is constant, so we will put it outside and we will take the derivative of x. Now cos 3x and 3, derivative of x is 1, so there is no need to write 1, so 3 cos 3x. Similarly, derivative of theta, for example, we have secant 6 theta. So derivative of secant theta is secant theta tan theta. So we'll write this is we consider as theta. Derivative of secant theta is secant theta and tan theta. Here angle is 6 theta, so we'll write angle 6 theta and 6 theta. Now again this is not 1 theta, this is 6 theta, so we will take the derivative of this angle. This is 6, this should be a 1. If this is not 1, so we will take the derivative 6, so secant 6 theta tan 6 theta as it is, and derivative of theta, the derivative of theta with respect to theta is 1 and 6 is constant, so we'll write outside, and derivative of theta with respect to theta is 1, so there is no need to write 1. So derivative of 6 theta is 6. Derivative of secant 6 theta is equal to 6 secant 6 theta tan 6 theta. Now Now we will solve question part 1. First of all, the first step is differentiation. We will suppose let y is equal to x square secant 4x. Now we can see that there are two terms, first term and second term. So here we apply product rule. Here we apply product rule and we will differentiate. In the right side variable is x, so we will differentiate with respect to x. Differentiate with respect to x. dy by dx is equal to product derivative and any two product variable is u derivative of v plus v derivative of u. So we consider this term as u and we consider this term as v. So u is x square derivative of secant 4x plus v is secant 4x and derivative of u is x square. Now x square as it is and derivative of secant theta is secant theta tan theta. Derivative of secant theta is secant theta tan theta. Here theta is 4x. Sorry. Theta means secant x 4x secant x tan x. And derivative of secant x is equal to secant x tan x and derivative of secant 4x is secant 4x tan 4x. Now I told you earlier that this angle should be 1. Now this is not a 1 angle, this is 4 angle, means 4x. So again we will take the derivative of this angle. Angle is 4x plus secant 4x. This is our angle. Now derivative of x square. Here we apply power rule. According to power rule, derivative of x square is n is 2. X 2 minus 1 becomes 1. So derivative of x square is 2x. Now x square secant 4x tan 4x and derivative of 4x. 4 is constant, so we write outside and derivative of x with respect to x is 1. So there is no need to write 1 plus 2x secant 4x is equal to 4x square secant 4x tan 4x plus 2x secant 4x. Now 2x secant 4x and 2x secant 4x is common, so we'll take a common 2x secant 4x. What is left? 2 2's are 4 and 1x is common and 1x is left. Secant 4x is common. What is left? Tan 4x plus this whole term is common, so 1 is left. This is our required solution.